In this video I'm going to look at some Leaving-Cert ordinary level questions from the exams. First question then. The first three stages of a pattern of grey and white tiles are shown in the diagram below. Draw the next stage. Okay, so if we see the pattern, there's 4 grey, 1, 2, 3, 4, and then 2 white. Then there's 9, so 3 and 3, and 2, and then 4 and 4. So the next one will be, again, you should be doing with a ruler. 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. Okay, so with a ruler that should be 25 grey ones, and then a white one up here, and a white one down here. Right, based on the pattern below, show the table, or complete the table. Number of grey tiles. Well, the number of grey tiles, there will be 4, and then 9, and then 16, and then 25, and then 36. If you can see, it's, look, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. And the number of white tiles, well, that doesn't change, that's always 2. So that will be 11, 18, 27, and 38. Okay, assuming the pattern continues, the total number of tiles, so total number, is given by this formula. Find the value of A and B. Okay, so here's our Tn equals n squared plus Bn plus C, and we have to find B and C. Well, let's look. On my first pattern, there is 1, 2, 3, 4, 5, 6. Okay, so my first pattern, 6 tiles. So that means if I put in 1 for n, okay, so if I put in 1 for n, I should get back out 6. Okay, so let's tidy this up. 6 equals 1 squared is 1, plus b multiplied by 1 is b, plus c. So I'll be left with b plus c equals 5. Okay, so there's an equation, a simplified equation. Likewise, if I put in, or on my second pattern, okay, so on my second pattern up here, I have 11 tiles. So if I put in 2 for n, so watch this, Tn equals n squared plus Bn plus C. If I put in 2 for n, I should get back out 11. So let's simplify this a bit. 11 equals 4 plus 2b plus c, which should give us 2b plus c equals 7. So there's my next equation. I'm going to write that equation over here. 2b plus c equals 7. It didn't give us much room to do this on our real exam paper. Okay, so I'm just going to rub out this. I would have liked more room, to be honest. Okay, so now I have 2 equations, and this is how you approach all these questions. I have 2 equations. B plus C equals 5. 2B plus C equals 7. So I have 2 equations, 2 unknowns, B and C. Yep, you've guessed it, simultaneous equations. So first of all, I need to change the signs. So that'll be a minus, that'll be a minus, that'll be a minus. Add vertically now. B and minus 2b is minus b. C's cancel. 5 and minus 7 equals minus 2. Minus b equals minus 2, so b equals 2. And I take any one of these equations again. Okay, I'll take the b plus c equals 5. But I know b is 2, so I put in 2 for b, so that means c equals 3. So C equals 3. And find the value of B and C. Well, there it is. Okay, so next they say find the number of the stage which has 443 tiles in total. Okay, so I'm going to take this Tn formula equals n squared plus, now I know what B is, it's 2n, and I know what C is, it's 3. And we're going to approach all these questions this way. Right, so we're asked now, what number do I put in for n in order to give me out 443? And that's what I have to try to find. So we have n squared plus 2n plus 3 equals 443. So what number do I put in here? Right, I'm just going to tidy this up a little bit first. So we have n squared plus 2n plus 3, and then bring the 443 across, and we get minus 440 equals 0. Right, we could do trial and error. We could put in numbers for n and see what number will we successfully get as 0 equals 0. Yeah, we could do that. That would be no problem. We could also use a minus b formula, because remember, look, this is quadratic, so we could say, well, a equals 1, because there's a 1 in front of that, b equals 2, and c equals minus 440, and throw them into our minus b formula. We could definitely do that as well. Or we could factorize. We could look for numbers that multiply together to give us 440, and that would be 20 and 22. That would be a plus. This would be a minus. N minus 20 equals 0. N equals 20. Or n plus 22 equals 0. N equals minus 22. And n can't be a minus number, okay, because like we're looking for what stage in the patterns it doesn't go down to minuses, so n has to be 20. Right? The trial and error version will be just like this: 2n plus, or sorry, n squared plus 2n minus 440, and start throwing in numbers. So if I threw in 10 here, that would be 100 plus 20 minus 440 equals 0, and that would be is it 120 minus 440 equals 0, which is 300 minus 320 equals 0. So 10 is not big enough, so we choose a bigger number. Okay, might choose 25, and sooner or later you're going to get to realize that actually if we put in 20 here, it should work. So 0 equals 0. Okay, so to answer our question, find the number of the stage which has 443 tiles. Well, it's stage 20. Okay. Next one. The first three patterns in a sequence of patterns of tiles are shown in the diagram below. Draw the next pattern. Okay, well, that's 3 across, 2 down. So 1, 2, 3, and then 2. 1, 2, 3, 4, and then 3. 1, 2, 3, 4, 5, and then 4. So we have 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. And there should be 5 down. So 2, 3, 4, 5, 2, 4, 5, and that's that done. Okay, next, based on the pattern shown, complete the table below. Pattern 1 has 5 tiles, as it does. Pattern 2 has 1, 2, 3, 4, 5, 6, 7, 8. Pattern 3 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Pattern 4 then has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And if we notice, it's going up in threes, so that'll have 17. Okay, so it's a linear pattern. By the way, when you're drawing this, make sure you do it in English, okay, with a ruler. Assuming that the pattern continues, the number of tiles in the nth pattern of the sequence is given by the formula Tn equals Pn plus Q. Find the value of P and Q. Okay. Again, all we do is, well, if I put in 1 for n, so we have p1 plus q, it should spit me out 5. So that means p plus q equals 5. So there's one equation. And if I put in 2 for p, that's q, it spits me out 8. Okay? Because look, I put in 2, I get 8. I put in 1, I get 5. So 2p plus q equals 8. So there's my next equation. So 2p plus q equals 8. Write it over here. Again, in this they didn't give me much space. I'll use simultaneous equations to find p and q. So p plus q equals 5. 2p plus q equals 8. Change my signs. Put the minus, minus, minus. Minus p and 2p is just p. Minus q and q cancel each other out. Minus 5 and 8 is 3. So p is 3. And so we know what p is. And now we're going to take this equation. P plus q equals 5. And I know p is 3, so 3 plus q equals 5. So q equals 2. So I found the value of 2 in p and q. How many tiles are in the 20th pattern? Okay, well, I'll take my Tn formula. So Tn equals Pn, but I know p is 3n, and I know q is 2. So I want to find out how many tiles are in the 20 pattern. I just put 20 into my Tn formula. So 220 equals 3 20s plus 2, which will give me 62. So 62 tiles. Find which pattern has exactly 290 tiles. Okay, again we take our Tn formula. We could do trial and error, so we could see, 3n plus 2 equals 290. We could do trial and error. We could start putting numbers in for n, okay, and seeing which one of those will give us 290. Or we could do a bit of algebra. Take 2 away from this side, 2 away from this side, we're left with 3n equals 2, 8, 8. And then we divide by 3 on this side, we get n, and divide by 3 on this side, and we get 96. So which pattern has exactly 290 tiles? The 96th pattern. Next one. Show that Sn equals 3n squared plus 7n plus 2 is the formula for the total number of tiles needed to build the first pattern. Okay. So, we're looking at the Sn formula. So, Sn equals n over 2, 2a plus n minus 1 d. And I need this, and after taking this from the logbook, okay, because that's the formula for the solve the first however many patterns, and I need that to look like that. Okay, so let's see. N over 2. Now a is the first term, and that is 5. Okay, I get that from here. Plus n minus 1. And then the common difference is, well, 5 to 8 is 3, 3 to 11 is 3, 11 to 14 is 3. So the common difference is 3. So n over 2, 2 5s are 10, plus 3 multiplied by n is 3n, and 3 multiplied by minus 1 is minus 3. Okay, again they're not giving me much room, so I'll do it over here. So we have n over 2. We have the 10 minus the 3, and then 3n, so we have 3n minus 7. And we need to make this look like this. Okay. Well, first thing we'll do is we take that 2 and we put it all over the 2. Okay, we can do that. So we have n, 3n minus 7 over 2. Okay, so from here to here is the exact same. Okay. And then we just multiply the n by the 3n and the n by minus 7. And we get 3n squared minus 7n all over 2. And that's our SN formula. And there we go. And, well, there it is up there as well. Find the total number of tiles needed to build the first 30 patterns. Okay. Sn equals 3n squared minus 7n over 2. That will allow us to find however many tiles we need to build the first however many patterns. I want to find out how many tiles are needed to build the first 30 patterns. So it will be 3, and we put in 30 squared minus 7, 30 over 2. We could just throw it into a calculator, but let's do it out. So we have 30 squared is 900, and 900 multiplied by 3 is 2,700 minus 201 over 2, and that will give us 1, 2, 4, 5 tiles. Okay, so we need that many tiles to build the first 30 patterns. Okay, that's it guys, thanks.